Okay, here's the recording in progress. I'll share the screen. All right, so I hope you enjoyed your day off, but now we're back to business. Okay, so today's just a review day. As soon as I finish my little bit of blabbing, you can ask me questions about the tests. So we are here. I'll say the usual 5-minute spiel that I normally give. Again, it's just a lot of repetition, but it's just to protect myself that nobody should have an excuse. I didn't know what the rules were and so forth. Okay, so we have our third exam tomorrow. As soon as class is over today, you may start submitting the homework. Okay, so you are responsible for 8.1 through 9.3, everything here. You must submit at least 70% of the homework. That should be easy to do since I do a great percentage of the problems, in which case all you have to do is just copy those and just work on the rest. All right, showing up is mandatory. I realized these lectures, they're optional except for, as I said, exams. So actual attendance, optional, 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 optional. You can just watch the video, but not on exam days. Okay, so actual exam tomorrow. Have your camera on, true background behind you. First and last name as on my roll sheet. Don't make me guess who you are. Keep yourself muted. If you have any questions during the exams, put them in the chat. Okay, I'll usually send the exam maybe around 8:01, 8:02, something like that. And on Canvas announcements, same place as I send all the videos. So don't look for it under Canvas quizzes or anything like that. Just look for the exams on Canvas announcements. And then I'll close the session at 9 o'clock. Then you have until 9:05 to take pictures on your cell phone. And you have until 9:30 to submit the homework. Okay, so that's the way that's going to work. So next exam is going to be on the 29th. And then we only, quote unquote, have one last exam, but as you can see, that's our longest exam. Sorry, not longest exam, longest chapter in terms of what's going on right here. Okay. All right, let's see. Did I miss anything? So keep yourself muted. Any questions, put them in chat. If you have to step away, let me know. Step away to get a drink of water, go to the bathroom. That's fine. Just let me know ahead of time. If you haven't already done so, have your one cheat sheet, your one formula sheet, something like this, standard size, 8.5 by 11. You can write on both sides. And yeah, please separate email for the exam and the quiz. All right, so I don't get the two mixed up. And of course, in the subject line, put that, subject line, this is the homework, or this is the test, or whatever. Okay, so please have them separate. Some of you have thought before, hey, how come I didn't get a score on my test? It may have been because you put the test and the homework on the same email, and I thought you were just doing the homework. Okay, and that's it. I don't look at the homework very carefully at all. It's pretty much just you did it or you didn't do it, and that's pretty much about it. Okay. What else? Maybe I'll let you ask now. So, do you have any questions about the test format itself before we get to specific questions on the test? Okay, so any questions about test format or how it works, so forth? All right, I don't see or hear anything. All right, so at this time you may start asking me questions about material. You can put them directly in the chat, I guess, or you can unmute yourself, but I think the chat is probably easiest. Okay, so I have already done 10.1. So when we start back up on Monday, I'll go on to 10.2 and we'll take it from there. But for today, let's focus on everything here. Okay, so I do see some things in the chat now. So let me get started with that and take a look. Okay, so 8.1, 8.2, 9.1, 9.2, 9.3, 8.2, 13, 9.17 A, B, C, 9.2, 24, 9.3, 19, 8.2, 11, 9.1, 4, and the actual 22, right? Okay. 8.2. Okay, I think I got enough to get started. Again, it's hard for me to read the chat and lecture at the same time. Ideally, I have somebody doing that for me. So if I end up not doing your problem, just put it back in the chat once again, but I think I have enough to go on right now. So let's get started. Okay, 8.2, number 11 and 13, it looks like. Let's see what it's about. Okay, 8.211. Okay, I will go ahead and give you a secret, I guess, or whatever. 8.211, it's very long. Okay, so I think to save us time now, it's a good problem to go in its entirety, but it's too long. I will not ask this very question in its entirety, although I might ask you for a setup for part of it, but it's really long. Okay, so that being the case, I don't want to take up too much of our class time with it now, unless I have spare time at the end. So I'm going to hold off on doing 11. 13, 8.213. Okay, let me see if I can do that one. (8.213). X is a function of y. 1/3 y squared plus 2 to the 3/2. Y is between 1 and 2. And we're spinning about the x-axis. So spin about the x-axis means we're integrating 2 pi y. Dx dy is 1/2 y squared plus 2 to the 1/2 times 2y. Cancel, cancel, which is y radical y squared plus 2. One plus dx dy squared is 1 plus the square of this is y squared times y squared plus 2, which is y to the 4th plus 2y squared plus 1, which is y squared plus 1 quantity squared. Very conveniently. I can get this into focus. Okay. So surface area is integral from 1 to 2, 2 pi. Okay, spin about the x-axis means 2 pi y. And since I'm integrating the respect to y, I can leave it as y. And then the square root of y squared plus 1 squared dy. Square root of a square cancels out, so that cancels out. Take out the 2 pi. And you go from 1 to 2. So I have y times y squared plus 1. That's y cubed plus y. Dy equals 2 pi y to the 4th over 4 plus y squared over 2. From 1 to 2. 2 pi. Plug in 2. 16 over 4 is 4. 4 over 2 is 2 minus 1/4 plus 1/2, which is 2 pi. 6 minus 3/4, which is 2 pi. That's going to be what, 5 1/4? 5 1/4, 21 over 4. So 21 pi over 2. Okay, 9.1, 4, and 7. (9.14) for what values of r, values of k, 4y double prime equals negative 25y. Y equals cosine kt. Okay, so y prime is negative k sine kt. Y double prime is negative k squared cosine kt. Plug in. 4y double prime is negative 4k squared cosine kt is equal to negative 25y. The original y is negative k sine of kt. Okay, that's a double negative. Throw this over. 0 equals 25k sine kt minus 4k squared. Let's see. Should be cosine. Sorry. I put the derivative when I should have put the original. Cosine kt. All right, so that follows that up. Y double prime times 4 equals negative 25 times the original. Okay, I think we're right now. Let me check something here. 4y double prime equals negative 25y. Okay, negative k sine negative cosine negative. Okay, so negative. The original has it. 4y double prime. So 4 of these, right? Equals negative 25. That, okay. I think I got it now. Something's not right here. 4y double prime equals negative 25y. Y is this, y prime is that, that's correct. Y double prime is that should be correct. Negative 4 times, 4 times this, negative 4k squared equals negative 25 times that. Multiply both sides by negative 1, k squared cosine kt equals 25 cosine kt. Okay, I think I got it now. So that means k squared equals 25, or k is plus or minus 5. Okay. And then after that, it's show and tell. So y equals cosine 5t, or y equals cosine negative 5t. And actually, these are the same thing. Cosine of 5t is the same as the cosine of negative 5t. So if I prove it for one, I've already proven it for the other. Okay, but now they say, for those values of k, verify that every member of the family of functions, blah, 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 is also a solution. Now show and tell. Y equals a sine 5t plus b cosine 5t. Show that this works. Okay, so y prime is a cosine 5t times 5. Derivative of this is minus 5b cosine 5t. And y double prime is negative 25a sine 5t minus 25b sine 5t. This one should be sine here. So this one should be cosine. Sorry, making a lot of mistakes today, it looks like. Derivative of that is that. Derivative of that is that. Okay. All right, so show and tell time, 4y double prime, 4 of these, negative 25a sine 5t minus 25b cosine 5t is negative 100 a sine 5t minus 100b cosine of 5t. And it's supposed to be the same thing as negative 25y. So negative 25 times the original y what did I do there? A sine 5t plus b cosine 5t. Negative 25a sine 5t minus 25b cosine 5t. And something's wrong. I'm not getting in the match, so I've done something incorrectly, evidently. And I can't find a mistake right now. So the only thing I can say right now to save time is I messed up. It'll take too long to fix it. So I would not get full credit on this problem, it looks like. But I got the idea. So the idea is I must have hit some arithmetic error or a sign error somewhere. But in the interest of time, let me go on and do more problems. So it looks like I botched this problem up. But let me go on. I'm so sorry about that. Number 7. You did not have to do A. B, verify that all members of the family, blah, blah, blah. Okay, y equals 1 over x plus c equals x plus c to the negative 1. Differential equation is y prime is negative y squared. Okay, so y prime is negative x plus c to the negative 2 times 1, which is negative 1 over x plus c squared. And negative y squared is the opposite of 1 over x plus c squared, which is negative 1 over x plus c squared. Okay, so that works. That's B. C, can you think of a solution which is not a member of the family? Very easy one is y equals 0. The derivative of 0 is 0, and negative 0 squared is also 0. So the answer to part C is simply y equals 0. Okay, that takes care of that. Okay. 9.2, 24, and 22. Euler's method. Y prime is y plus xy, which is y times x plus 1. Y of 0 equals 1. Okay, so this is one of those where I think in the interest of time, I won't do the entire problem. I might just do a couple of iterations. All right, so step size is 0.2, 0.2, 0.4, 0.6, 0.8, and 1. Okay, so 0, 1. Slope is, plug in, 1 times 1, which is 1. Delta y is m delta x, which is 1 times 0.2, which is 0.2. Root point is 0.2, comma 1.2. Okay. Delta x was 0.2, delta y is also 0.2. Now I plug back in to find this new slope. So it's y times x plus 1. Y is 1.2. X plus 1 is also 1.2, which is 1.44. Delta y is m delta x, which is 1.44 times 0.2, which is 0.288. So the new point is 0.4, comma 1.2 plus that is 1.488. And I think I'll just say et cetera. If you got these two correct ideas, so they're just follow the same pattern all the way through. Okay, get that one. So that's that. '24. Y prime equals cosine of x plus y. Y of 0 equals 0. Step size 0.2. 0, 0.2, 0.4, 0.6. Okay, so 0, 0. First slope is a cosine of 0, which is 1. Delta y is m delta x. 1 times 0.2, which is 0.2. 0.2, comma 0.2. So m is the cosine of the sum, cosine of 0.4. Has to be in radians. Make sure I'm in radian mode. Cosine of 0.4. 0.92. 106. 1, roughly. Delta y is 0.921061. That's m times delta x. Divided by 0.2. 0.184212. So 0.4, comma, that plus that is 0.384212. And we just have to do it one more time. Do I want to do one more? I think, okay, we'll go ahead with it. So m is the cosine of that plus that. That plus that is 0.784212. And 0.4 to my answer. 0.834. 147. Delta y is 0.834147 times 0.2. And 166.829 roughly. 0.6, comma, whatever that plus that is, roughly 0.55. I'll just say roughly 0.55. So y of 0.6 is approximately 0.55. I know there's a part B, which says step size of 0.1, but it's the same concept. So I think I'll just stop there for that particular problem and move on. 9.319. Then I would be done. So you can ask more questions in the chat, but if not, I'm going to go back and see if I can fix the one I messed up and maybe get started with that one that I said I wouldn't do in its entirety. 9.319. Okay, slope means y prime is x over y and 0, 2. So it's like they're saying y of 0 equals 2, dy dx is x over y. Okay, so cross multiply, y dy equals x dx. Integrate. Y squared over 2 equals x squared over 2 plus c. Multiply both sides by 2. Y squared equals x squared plus 2c. 2c is just c. And then square root, plus or minus. Y is plus or minus the square root of x squared plus c. And now y of 0 equals 2. The meeting will end in 10 minutes. I don't even know why they do that. That happened last time, didn't it? Well, let's see how much we can do. Okay, so I put a 2 here equals plus or minus the square root of x c. And that means I want the positive, I don't want the negative. Square both sides, 4 equals c. So y equals square root of x squared plus 4 seems to be the answer to that one. Okay. All right, I think I've caught up. Let me go back and check the chat. If we're still going into it and I accidentally get bumped out in 8 minutes, then I'm going to join back in. So let's see. Okay, I think I've caught up from the chat. So let me go back and try to fix the ones that I did before. All right. I think you got the idea for the trig one that I boxed up. So let me start the one that I didn't do it at all. So again, I will not ask you this particular question in its entirety, but only maybe part of it. That was 8.2, number 11, right? As I recall, this thing requires maybe 3 substitutions. From 0 to pi. Okay, so dy dx is negative 1/2 sine half x. 1 plus dy dx squared is 1 plus 1/4 sine squared half x. So the surface area is integral from 0 to pi. 2 pi. We're integrating about the x-axis, so it's 2 pi y. Here's the original y. And then radical 1 plus 1/4 sine squared half x dx. First thing I'll do is get rid of the half x. I don't like the half x. So how about t equals half x? dt is 1/2 dx. So 1/2 here, 2 here. X equals 0. T equals 0. X equals pi. T equals pi over 2. So the integral is 2 times integral from 0 to pi over 2. 2 pi cosine t radical 1 plus 1/4 sine squared t dt. Now I'll do a trig substitution, call that u, let's say. U equals sine t, du equals cosine t dt. T equals 0, sine of 0 is 0. T equals pi over 2. Sine of pi over 2 is 1. Take out the 2 pi, so I have 4 pi. You go from 0 to 1. So radical 1 plus 1/4 u squared du, which is 4 pi integral from 0 to 1, 1 plus u over 2 squared du. Okay, I don't want u over 2, so I'll do another simple substitution. Running out of letters. I'm going to call this v. V equals u over 2. dv is 1/2 du. 1/2 2. U equals 0. V equals blank. U equals 1. V equals blank. V is u divided by 2. 0 divided by 2 is 0. 1 divided by 2 is 1/2. So my new integral is 8 pi, 4 pi times 2. Integral from 0 to half of radical 1 plus v squared dv. Okay, and then one more substitution. See how much I can do before the computer bumps me out. V is tangent theta. dv is secant squared theta d theta. V equals 0. Tangent of 0 is 0. V equals 1/2. Theta is inverse tangent 1/2. Okay. So 8 pi integral from 0 to inverse tangent of 1/2. Radical 1 plus v squared dv secant squared theta d theta. Okay, and I'll have to say etc. here. After that, you'd have to integrate by parts, but you can see how long the problem is. And so maybe that's as much as I'm going to do for that particular one. Okay, quick check the chat real quickly. I'm not sure if we're going to get bumped out. So yeah, if I get bumped out, don't just leave. Let me see if I can get back in. 8.1, 15, 17, and 19. Okay. I do have a sneaky suspicion that when all is said and done, I would have almost literally done every problem, which might be you guys' strategy, but that's okay. I don't mind. Make sure you guys know how to do these problems. 8.115. Y equals ln secant x. 0 to pi over 4. Okay, so 1 plus dy dx squared is 1 plus, so derivative of this is 1 over secant x times derivative of secant x, which is secant x tangent x squared, which is 1 plus tangent squared, which is secant squared. Okay, so the arc length integral from 0 to pi over 4. I'm taking the square root of this guy. Okay, so the derivative again is 1 over secant x times the derivative of secant x with secant x tangent x. Cancel out, squared, tangent squared. So square root of secant squared is just secant. 0 to pi over 4 of secant x dx. Integral of secant, you can put it on your cheat sheet, ln absolute secant x plus tangent x from 0 to pi over 4 equals ln. Secant of pi over 4 is radical 2. Tangent of pi over 4 is 1. Secant of 0 is 1. Tangent of 0 is 0. That cancels out. So ln 1 plus radical 2 seems to be the best answer. 17. One-fourth x squared minus 1/2 ln x between 1 and 2. 19, I'll go ahead and tell you 19 is also very long. It's a good problem, but it's long. It ends up switching over to integration by partial fractions. So I will not ask you 19 in its entirety, maybe just a subset of it. We're getting up against that 10-minute mark that Zoom said was going to happen. So if it happens, hang in there. Hope it doesn't happen, but we'll see. dy dx is half x minus 1 over